Now we're going to take a look at finding the range of a function. So for college algebra, we're going to stick to finding the range of a graph. And then you do have a graphing calculator at your disposal. So whenever you're given an equation and you want to find a range, you can always graph it. And then we can use the graph to help determine a range. We're not going to look at expressions or finding a range of equations. And that's because in order to properly do that, for many of your equations, you're actually going to need a little bit of a calculus to help you out, and you're going to learn how to do that next year. So for this class, we're going to just stick to graphs. So we did a little of this before. So when you want to find a range of a function, it's the set of all possible y values. So you can look at the graph. Like I said, it's helpful to look at the graph to find the range. So if you have y equals negative 3x plus 5, I would graph it, and you can use Desmos or you can use the TI graphing calculator to assist you. And you're just going to see what's the lowest point on the graph, lowest possible point, and what's the highest possible point. And in this particular example, we see the two arrows at the end, so we know it goes down indefinitely, and we also know it goes up indefinitely. So our range is going to be plus and minus infinity in this case. And we can put that, see, I can denote, oops, I mean right there. So my range, I'm going to put it R, is going to be from negative infinity to infinity. So in here, we have another example. So here we also have a radical. So if you plot that out on the graph, you'll get that your lowest value, you can see, is negative 3/2, comma 0. And the thing is, you know that this cannot be below 0. So you can use that information to help you out a little bit as far as your domain, right? And once when you have your domain, you can get some sense of the range, but it's limited. So I would recommend you graph it. If you have a good software program, you can actually like hover over this and get that point. And we see that negative 3/2, 0, that's your leftmost point, and we can include that. And then it goes on this side, on the right, it goes up indefinitely. So for your range, and we're just thinking about how far up or down the graph goes. And I know some people accidentally, you confuse the domain and range, and I just put a D, see? You have to put an R. So the lowest point we have is at y equals 0, so I'm going to put a 0. And then the highest, because it goes up and to the right indefinitely, it's going to be positive infinity. It's moving slowly, but it's moving. So that will be the range. So let's take a look at a couple more examples, and then I'm going to have you try. So suppose you have something a little more complicated. So g of x is equal to the square root of x plus 5 over x squared plus 1. This is lots of fun. However, with the magic of technology, you can just go ahead and graph this in your graphing calculator or on Desmos, and you will get a graph such as this. So and this graph helps you identify the minimum and the maximum of your graph. And then we're just going to look for the lowest y value, the highest y value. In this case, our lowest y value would be 0, and our highest y is the square root of 5. And in both cases, we don't have any open circles or open intervals, so we're going to include that 0 and 5. So when I put my range, I would start at 0, and I would go up, I think I said 5, but it's to go up to the square root of 5. And we can include both. And then finally, we have another interesting graph. So here we're graphing negative 3 over 2x plus 1. And notice that we need to avoid the values that will make this equal to 0. And we know, and if you're not sure, negative 1/2 actually will make this denominator equal to 0. So our graphs are avoiding it. Notice that we have this interesting behavior. We actually call this an asymptote. So actually at negative 1/2, it's kind of like an invisible wall. So this graph is really avoiding that value. But when we write out the domain, we need to think about, okay, what's our highest, what's our lowest, but also we have to consider, is there anything that we're avoiding here? And it looks like the value that's being avoided, we have an asymptote right here too along our x-axis. So it's not making it to 0. And if you think about it, like there's no way to divide, like what can you divide 3 by that will give you a 0? Well, that doesn't happen. So this graph right here is avoiding 0. When I write up my range, I know I can have anything below 0, clearly. So I can have negative infinity up to 0. I'm going to have a u. I'm going to unite it with everything above 0. So from 0 to positive infinity. And that's my final answer. If you weren't sure what this value was, you can always take, your calculator. You can hone in on this value. But again, a lot of times you can do this by reasoning, but eventually you're going to need some calculus to actually just get you a value without using the graph. And now what I want you to do is go ahead and you're going to complete some practice questions. So you're going to go through the different questions and determine the range for a different question. So I'm going to just kind of flip through them. So there are a few more questions here before we get to our next section.